Welcome to The Explainer. Today, we're diving into Cilium, a technology that's completely changing the game for networking, security, and just plain seeing what's going on inside Kubernetes. If you've ever heard about the sidecar model and wondered what's next, well, you are in exactly the right place. Okay, so here's our plan for today. First, we're going to tackle the big problem. Why did cloud-native apps make networking so ridiculously hard? Then we'll look at the first real fix, what I'm calling the era of sidecars. After that, we'll get into the eBPF revolution, which is the real game changer here. We'll see how Cilium actually uses that tech. We'll unpack its three main superpowers, and then we'll zoom out and look at what this all means for the future. So, to really get why Cilium even exists, we have to rewind a bit. We've got to ask the fundamental question it was built to solve. Why is Kubernetes networking just so notoriously difficult?
Look, Kubernetes was an absolute revolution for deploying apps. It made everything super agile, super scalable. But, and this is a big but, it created this massive new headache. When you have services constantly spinning up and down, how in the world do you manage their performance, keep them secure, and actually see what's going on with all the traffic flying between them?
I mean, think about it, right? The old school rules of static IP addresses and firewalls just completely fall apart when your applications are being created, destroyed, and moved around a cluster literally every few seconds. The old tools just were not built for this world.
Okay, so the industry needed a fix. What was the first real attempt to solve this mess? Well, that brings us to the service mesh and its main workhorse, the sidecar proxy.
The idea was actually pretty clever. Instead of stuffing all that complex networking logic inside every single one of your applications, you just pull it out. You put it in a dedicated proxy container, like the super popular Envoy proxy, that runs as a sidecar right next to each of your apps. And this model gave us a ton of value, for sure. It really got the industry where it is today, but it wasn't a silver bullet, not by a long shot. It came with some major trade-offs, making it what you might call a necessary evil. And this slide, man, it just lays out that trade-off perfectly. Let's look at the good stuff first, the pros. Sidecars solved some huge problems. They were single-tenant, which meant no more noisy neighbor issues. But then you look at the other side of the ledger, the cons, and whoa, they brought a whole new world of pain. They ate up a ton of CPU and memory. They made things way more complex. And maybe worst of all, if you wanted to upgrade your networking layer, you had to restart every single one of your applications. Ouch. And this is where our story takes a really cool turn. All that pain from the sidecar model, it created this huge opening for something new, something, well, revolutionary. A technology popped up that promised all the good stuff from the service mesh, but without all those painful trade-offs. That technology is called eBPF. Now, stick with me here. The easiest way to think about it is like this. The Linux kernel is the absolute core of your operating system. Think of it like the central nervous system that controls everything. Well, eBPF is like a safe, controlled way to inject new skills directly into that nervous system. It lets you run these tiny, super efficient programs right where the action is happening, especially for networking, without having to mess with the core OS code itself. And this right here, this visualizes the huge difference. In the before picture, with sidecars, network traffic has to take this long, slow detour. It leaves the kernel, goes all the way out to a separate proxy, and then has to come all the way back. But look at the after. With eBPF, the logic is right inside the kernel. There's no detour. It's a straight shot. And the result is just a massive boost in speed and efficiency. Okay, so eBPF is this incredible raw technology. But how do you actually use it to build something? Well, that's where Cilium comes into the picture. Cilium is the project that harnesses all that eBPF power to build a totally new, modern way to do cloud-native networking.
So, Cilium's architecture really boils down to three main pieces. First, on every single machine, every node, you've got the Cilium agent. This is the powerhouse, the thing that uses eBPF to manage all the traffic. Then you've got the operator, which handles the big picture, cluster-wide jobs. And finally, there's Hubble, which is your window into everything, giving you incredible visibility into what's actually happening on the network.
Okay, but wait a second. This brings up a really good question. If eBPF is so amazingly fast and efficient, why is a proxy like Envoy still in the picture at all?
And here's the key distinction. I love this analogy. Think of networking like sending mail. eBPF is an absolute superstar at what we call layers 3 and 4. That's like the Postal Service knowing all the addresses and zip codes. It is blazing fast at getting the envelope to the right building, but layer 7, that's about what's inside the letter, the actual language, like an HTTP request.
For that deep, application-level understanding, you still need a specialist, and that's Envoy. So Cilium is super smart about this. It uses eBPF for all the high-speed routing and only brings in Envoy when it absolutely needs to read the mail.
So when you put all this together, this eBPF foundation without the clunky per-pod sidecar, you give Cilium what you could honestly call 3 networking superpowers.
Okay, superpower number 1, high-performance networking. By doing the work in the kernel instead of a sidecar, everything is just dramatically faster with way less overhead. Superpower number 2, security that's actually granular and makes sense. Instead of relying on flimsy IP addresses, security is based on a strong cryptographic identity. It's like giving each service its own passport. And number 3, deep observability, without the performance penalty. With Hubble, you get this incredible insight into your network, and it comes straight from the source.
All right, so what does all this mean for the bigger picture, beyond just one Kubernetes cluster?
And this is where things get really powerful. You see, Cilium can speak the old-school language of networking. It can use standard protocols like BGP. That's the protocol that basically runs the entire internet. This means it can seamlessly connect your new, shiny Kubernetes world with your existing data center. And all of a sudden, you have one unified view for security and observability that covers your old legacy apps and your modern cloud-native stuff. It really does bridge that gap.
And that leaves us with this final kind of mind-blowing thought. As tech, like eBPF, gets more and more common, we might be watching a fundamental shift in computing. The kernel itself, the very core of the operating system, is becoming the next great platform for innovation in the cloud. It's not just about what happens on top of the OS anymore, but what we can now build inside of it.